This is a supplemental video to help you with addition, subtraction, multiplication, and division when it comes to scientific notation. The first thing we're going to deal with is addition and subtraction. So a review, scientific notation expresses a number in the form m times 10 raised to the nth power. M has to be a number between 1 and 10, and n is any integer. Here we have 4 times 10 to the 6th power plus 3 times 10 to the 6th power. So if the exponents are the same, that times 10 to the 6th, if the exponents are the same, we simply add or subtract the numbers, the m value, in front and bring down the exponent unchanged. So we have 4 plus 3 is 7. Bring down the times 10 to the 6th power. Simple enough. However, if the exponents are not the same, we must move a decimal to make them the same. Here we have 4 times 10 to the 6th plus 3 times 10 to the 5th. So those are different exponents. We have to move a decimal to make them the same. My suggestion to you is to move the decimal on the smaller number. Here, 3 times 10 to the 5th power is the smaller number, not because 3 is smaller than 4, but because the exponent 5 is smaller than the exponent 6. So we're going to move the decimal on that value. We're going to move the decimal one place to the left. That will allow us to rewrite our equation as 4 times 10 to the 6th power plus 0.3 times 10 to the 6th power. Now we've achieved that situation in which our exponents are the same, and we can go on with the addition of the m values. 4 plus 0.3 equals 4.3 times 10 to the 6th power. Now it's time for you to try. I want you to try adding 2.37 times 10 to the negative 6th and 3.48 times 10 to the negative 4th. Go ahead and press pause on the video so you can have a chance to attempt this problem. Well, we find we have the issue. Our exponents are not the same, so we cannot go forward with the calculation quite yet. We have to make sure that these two exponents are the same before we can carry out this addition. Now, I suggested that you choose the number that is the smallest. This is being multiplied by 10 to the negative 6th power. Negative 6 is smaller than negative 4, so this actually becomes the smaller number. So I am going to move the decimal 2 places to the left so that I can rewrite this system of this equation as 0.0237 times 10 to the minus 4 power plus 3.48 times 10 to the minus 4 power as well. Now that my times 10 to the negative 4 powers are the same, I can carry out the addition of the m values and carry down my times 10 to the minus 4th. So here are the things that you need to keep track of. First, make sure the exponents of 10 are the same. Then move on to dealing with the m values. The key to adding and subtracting numbers in scientific notation is to make sure that the exponents are the same. Let's move on to multiplication and division. Multiplication has a slightly different rule than division here when dealing with scientific notation. When multiplying in scientific notation, you multiply the coefficients together. That's the m value. Then you add the exponents, and the base 10 will remain. So here, I'm going to allow you to press pause on the video. Be sure to multiply the m values and add the exponents and see what we come up with. 2 times 3 is 6. The exponents 3 plus 5 equal 8, so we have 6 times 10 to the 8th power. Here's another one. Press play or press pause and give yourself an opportunity to try this problem. Carrying out the function 9.2 times 2.3 will get 21.16. Next step, add the exponents. 5 plus 7 equals 12. However, I hope you've noticed that this response is not in proper scientific notation. So if we were to put this into proper scientific notation, our m value would have to be between 1 and 10. So we'll move the decimal one place to the left. We'll have to adjust our exponent accordingly. But we'll end up with 2.116 times 10 to the 13th power. However, again, I hope you've noticed that we do not have the proper number of significant figures here. So we'll have to round down to 2.1 times 10 to the 13th power. One more chance. Pause the video and give yourself an opportunity to practice using this example problem. 3.2 times 1.5 is going to give you a value of 4.8 using the correct number of significant figures. Times 10 to the minus 8th. Again, we're multiplying the m values and then adding the exponents. Negative 5 plus negative 3 is negative 8. Moving on to division. When dividing with scientific notation, we divide the coefficients. So we divide the m values. Then we subtract the exponents. All the while, the base 10 remains the same. So here we have 6.20 times 10 to the minus 5th power divided by 8.0 times 10 to the 3rd power. Here, we're going to deal with the m value and the exponent separately. We have 6.20 divided by 8.0. The value that my calculator tells me is 0.775. Next, we move on to dealing with the exponents. Here, since we're dividing, we're going to take negative 5 and subtract 3. Well, subtracting 3 from negative 5 gives you a value of minus 8. But again, I hope you notice that this is not proper scientific notation because the m value is not between 1 and 10. So we'll move the decimal one place to the right to generate 7.75. We'll have to adjust the exponent a little bit. We'll have to make it smaller by 1 times 10 to the negative 9th power. Here's an opportunity for you to practice dividing numbers that are in scientific notation. Go ahead and press pause on the video so you can try this. Eight divided by 2 is 4. I have an exponent of 6 and an exponent of 3, so I'm going to divide 6 by 3. I'm sorry, subtract 3 from 6 to give me an exponent of 3. Here's your next practice problem. Go ahead and press pause so you can try this. .402 divided by 6.3 gives me a value of 0.54 using the correct number of significant figures, 2. Again, this m value has 4 significant figures. However, this m value only has 2, so my response needs to have 2 significant figures. I'm dividing these two values, so I'm going to take the exponents and subtract them from one another. I'll take 5 and subtract 7. That will yield minus 2. Again, I hope you notice that this is not in proper scientific notation. I'll have to move the decimal place 1 to the right. And when I move the decimal place 1 to the right, I'll have to adjust the exponent accordingly. Moving to the right makes that a smaller number. So the exponent will be smaller. It'll be 5.4 times 10 to the minus 3rd. Here's a set of 5 practice problems for you to practice multiplying numbers that are in scientific notation. Notice each one of these are multiplication. Please pause the video until you've generated an answer to each of the following problems. These are the answers that I've generated. Notice that I've taken care to make sure I conserve the proper number of significant figures. I hope you were able to do the same. Again, if you are not able to generate these answers even after I have shown you what they should be sure to bring that question into class. Here's another set of practice problems. This time we're doing division. Notice that each of these functions are division. Please pause the video so you can have time to do these now. Alright, here come your answers. Again, notice the scientific notation is still conserving the proper number of significant figures. I hope you were able to generate the same answers as I was. I hope you're able to mimic the procedure that I used. If this is not working out for you so far, you can, 1, try to watch this video again. 2, you can try to look up another video on YouTube, and hopefully the way someone else explains it will be better for you. 3, bring that question into class. And there's always something you can do to better understand the content. I'll see you next period.